Hello friends, good morning. Myself MB Gaddi, lecturer in electronics department. Now, today I am going to discuss regarding error detection and correction question banks. First question, describe briefly about an error. When the received digital data is not same as that was transmitted, error is said to have introduced. In single or multiple bits, there are two types of errors. First one, random errors. Second one, burst errors. Describe briefly about single bit error and burst error. Single bit error, only one bit in the data unit has changed. That is, only one unit bit of data will be changed. That is called the single bit error. Burst error. It means that two or more bits in the data unit has changed. Two or more. Single bit error figure shows 0 changed to 1. Burst error, that is bits corrupted by the burst error. Figure shows sent message and received message. Some bits are corrupted. Write a note on redundancy. Error detecting code is to include only enough redundancy to allow the receiver to deduce that an error occurred, but not which error, and have it request a retransmission. Error detection uses the concept of redundancy, which means adding extra bits for detecting error at the destination. Instead of repeating the entire data stream, a shorter group of bits may be appended to the end of each unit. This technique is called redundancy because the extra bits are redundant to the information. They are discarded as soon as the accuracy of the transmission has been determined. Figure shows redundancy diagram. Sender data will be there, generating function, sender, data and redundancy check, then checking the function, accept or reject, receiver. Write a brief note on block code. Principle of block coding. Figure shows channel encoder, message block input, code block output. Figure shows the functional block diagram of block coder, message, k bits, message, k, then check bits. For the block of k message bits, n minus k parity bits or check bits are added. Hence, the total bits at the output channel encoder are n. Such codes are called NK block codes. Illustrates the figure. Systematic codes. In the systematic block code, the message bits appear at the beginning of the code word. Thus, as shown in figure, the message bits appear first and then check bits are transmitted in a block. This type is called systematic code. Non-systematic codes. In non-systematic codes, it is not possible to identify message bits and check bits. They are mixed in the block. Explain briefly about FRC. It is also known as parity check. It is least expensive mechanism for error detection. In this technique, the redundant bit called parity bit is appended to every data unit so that the total number of ones in the unit becomes even, including PRC. Vertical redundancy check. Figure shows Vertical redundancy check. Checking function for the receiver is total number of ones even. Their data is 1100000111. Then vertical redundancy check, it can be checked at the even or odd numbers. The data is 100001. Sender is 1. Vertical redundancy check example. After adding the parity bit. Vertical redundancy check (VRC) can detect all single bit errors. It can detect burst errors if the total number of errors in each data unit is odd. VRC can detect errors where the total number of bits changed is even. Write a note on LRC coding method. In this method, a block of bits is organized in a table, rows and columns. Calculate the parity bit for each column and set of this parity bit is also sending with original data. From the block of parity, we can check the redundancy. LRC example. LRC example is given. Advantage: LRC on n bits can easily detect burst error of n bits. Disadvantage: if 2 bits in one data units are damaged and 2 bits in exactly same position in another data unit are also damaged, the LRC checker will not detect the error. Write a note on cyclic redundancy coding method. In this method, a sequence of redundant bits called CRC or the CRC remainder is appended to the end of the unit so that the resulting data unit become exactly divisible by a second predetermined binary number. At its destination, the incoming data unit is divided by the same number. If at this step there is no remainder, the data unit assumed to be correct and is accepted. Otherwise, it indicates the data unit has been damaged in transmission and therefore must be rejected. The redundancy bits is used by CRC are derived by dividing the data unit by predetermined divisor. The remainder is the CRC. CRC generator and checker. Figure shows sender and receiver. Data 00, n bits, divisor n plus 1 bits, n bits. CRC data, receiver data, CRC, divisor, remainder 0 except non-zero reject. Divisor. The divisor is predetermined according to the algebraic polynomial. For example, a polynomial is x raised to 7 plus x raised to 5 plus x raised to 2 plus x plus 1 generation of divisor form. This is the mathematical simulation, that is simplification. A polynomial should be selected according to the following rule. It should not be divisible by x. It should be divisible by x plus 1. Example, the CRC generator at the center. The message will be divided by 1101. The CRC checker at the receiver end. Write a brief note on checksum coding technique. This carries 5 marks. Principle: all bits in a data block being transmitted are added. and the sum is transmitted along with data. The receiver adds the bits in received data block and compares received, received checksum with the calculated checksum. If there is difference between received and calculated checksum, error is said to have introduced. Four methods are used to calculate the checksum. First one single precision, second one double precision, third one residue checksum, fourth one Honeywell checksum. Write the merits and demerits applications of checksum method for 5 marks. Merits of checksum. Most simple technique, easy to implement since only data blocks are added. Demerits of checksum. It is used only for error detection. Second one, specific error cannot be located. Applications. Checksums are typically used to compare two sets of data to make sure they are the same. Some common applications include verifying a disk manager or checking the integrity of a downloaded file. If the checksums do not match those of the original files, the data may have been altered or corrupted. Next one question, simple applications of error control scheme. It is for 4 marks. First one, transmission of data over internet. Second one, deep distance communications. Third one, digital satellite broadcasting. Fourth one, storage of digital data. Fifth one, error correcting memory. Explain ARQ control scheme. 5 marks. Encoder. It encodes the messages and inputs in the buffer. Input buffer and controller. It stores some of the previous transmitted code words. If there is a retransmit request on feedback path, then controller identifies the particular code word from buffer and sends it on the forward transmission path. Forward transmission path is the channel through which code words are transmitted. It can be a cable, fiber optic cable, or wireless media. Detector. The detector decodes the received signal and looks for errors in it. If no errors are found, then the positive acknowledgement ACK is sent to the transmitter on the feedback path. The positive acknowledgement is also sent to output buffer and controller. If detector finds any error in the received code word, then negative acknowledgement NAK is sent to transmitter on feedback path and output buffer and controller. The negative acknowledgement NAK is actually a retransmit request to the input buffer and controller. Output buffer and controller, it takes a code word from detector and stores temporarily in the buffer. Block diagram of ARQ system. The explanation already given. Describe about forward error correction and detection. Figure shows encoder, input message bits, transmitter, channel R equal to RB by C. Then it is given to summer, receiver, regenerator, decoder, output message bits. Figure shows the block diagram of FEC system. The input to the system are message bits at the rate R equal to B. The encoder takes the block of K message bits and generates a coded message of n bits. Thus, the code rate of the encoder becomes Rc equal to k by n, which is less than 1. The transmitter puts this encoded message off on some n suitable carrier and transmits over the channel. The bit rate of the channel R equal to Rb divided by Rc. At the receiver, the transmitted signal is received. The regenerator reconstructs the coded message. The decoder identifies the message bits and code bits. It then detects and corrects the errors, if any, in the received signal. Thus, in FEC system, no retransmission of the message is done even if errors are detected. The errors are detected and corrected from the code bits only. Describe briefly convolution encoding operation. 6 marks. Convolution coding is widely used coding method which is not based on blocks of bits but rather the output code bits are determined by logic operations on the present bit in a stream and a small number of previous bits. In the encoder, data bits are input to a shift register of length k called the constraint length. As each bit enters at the left of the register, the previous bits are shifted to the right while the oldest bit in the register is removed. Two or more binary summing operations, let's say R, create code bits which are output during one data flow period. Therefore, the code bit rate is 1 divided by R times the data rate, and the encoder is called a rate. 1 by R convolutional encoder of constraint length k. Figure shows convolution encoding. This ends fifth chapter, error detection and correction. It is also a very easy chapter. You have to prepare. For 5 marks and 10 marks, you have to write the matter which will be given. For if it is a 10 marks question, you have to draw the diagram and explain in detail. For 5 marks, diagram plus explanation. If definitions, 1 marks definitions, line write 2 sentences.